Good afternoon, everybody. I'm glad to be here at my first ACI convention. My name is Abdulrahman Salah, and I'm a PhD student at the University of Houston. I'm here presenting my experimental work regarding the shear behavior of UHPC considering axial effects. This work is with collaboration with my colleague, Ran Shaheen, who is here also to present and under the supervision of my advisor, Dr. Collins. So I'm going to start talking about the universal panel tester, which is the unique machine at the University of Houston Structural Lab. This machine allows testing concrete structures as a single element under any stress state that someone can test a concrete element. So it consists of 40 in-plane actuators and also 20 out-of-plane actuators. This combination of 60 jacks can produce any stress state. Our main concern here is to apply first, we are testing the UHPC panels under pure shear, and later on we are going to test UHPC panels under combined axial compression with shear and axial tension with shear. The panels we are planning to test are going to be reinforced and unreinforced ones. You can see here the universal panel tester while the specimen is inside. The new step in our the new concept in our test that we are testing this element just using one group of the actuators at the front, because our specimen is only 4 inches thick compared to the conventional concrete they used to test 7 inches thick specimens. It has been used extensively over 30 years, testing different material, different concrete strengths and composite materials. So as we can see here, we have 3 out-of-plane rigid links in order to keep the panel in its place and preventing any rotation during the test. And we are applying tension in the left and on the right, and applying compressive stresses at the top and at the bottom. This test will produce the pure shear stress state that we are targeting to investigate the UHPC behavior. As we can see here, this is the only, I assume this is the only way to test a concrete element under pure shear state. So the panel itself is installed into the machine, and the forces, the stress are applied in the principal directions, but the element under the test is the center area of the panel, and it's tested under pure shear. The panel's fabrication, as we can see here, we are reinforcing the edges of the panel in order to prevent any premature failure at the edges, especially in the tension sites. So we are putting the reinforcement, and we are attaching confining plates to the edges, which will strengthen the edges more, and then casting the HPC panel and connecting the inserts inside the concrete by bolts to the outer yokes, which is connected to the actuators, and then the stresses are applied. Here are the steps that we follow to fabricate the specimen by having pre-packages UHPC materials. It's dumped into the mixer, and then keep mixing the UHPC until having the desired consistency and the flowability is going well, and then adding the steel fibers to the mix. So we have the random. So we have the random distribution of fiber in between the mix. And here's the UHPC panel after casting. In addition to the material test level specimens, the steel fiber content was 2%, and the compressive strength of the UHPC material after 28 days was 19.2 KSI. So after testing the panel, as we can see here, we found that the test results, only we can see one crack to the, I think to the left of the slide. We can see the arrow is pointing that large crack, and that was the largest crack we found. No other large cracks, and the behavior of the panel was described in this graph. If we can see the shear stress versus the shear strain, starting with the linear behavior at the beginning. Actually, we tested the specimen starting by force-controlled load protocol in order to get the load stabilization, and then we switched the test into displacement control. That way we have all tension sides are applying tension and all compression sides are applying compression. As we can see from the curve, that elastic behavior is almost at the beginning, up to almost 80% of the shear strength, and then another linear segment, and we got this plateau, which is prior to the maximum shear stress, which was about 0.8 KSI. And the softening branch of that graph until stopping the test before having further cracks. Another graph is showing the tensile behavior of the UHPC panel compared to the shear behavior. As we can see, we have almost similar curves because the tensile behavior of the UHPC is governing the shear behavior of UHPC, as we have very high compressive strength of UHPC materials. And with this, it's just the first specimen that we are testing, and coming into the summary of the experimental work we have done. Further work will be conducted to the experimental results using the softened membrane model, in addition to test other specimens under the axial effects. And also one of the points that we conclude from the first test, that the end regions need to be confined more or strengthened, so we don't have any crack failure outside of the element of interest. By the end of my presentation, I would like to thank the Steel Light Company for providing the UHPC materials, and also ACI for their funding of this project. Thank you.